Let's revisit the little one-dimensional world that we had made earlier and see if we can enhance it a little bit by having us, the little creature, the me, find the food and automatically move to it instead of having to manually step to it one step at a time. So just to briefly recall what we had done before, we can see on the screen we have a variable called world, which is a list of cells, just a single dimensional list of cells, where we use an empty string to mean an empty cell, the string me to represent the creature where I am, and the string food to represent where the food is. We have a method called display world that will display the contents of the world in a prettier way. And we have a simple method called move right, which finds me and moves me one step to the right. What we have here is just a single call to display world. So if we run this, we will see that it displays the world, me over here and food over here. If we modify this to say move right and then display the world again and run it, then what we'll see is it displays two lines, the original line and the second line with me one step to the right. It looks like Mia has joined us. She is the friendly one. She doesn't scratch so much. Okay, so now what we want to do is have me keep on moving until it gets to the food and then eat the food. The problem is we don't know where the food is. I mean, we could find it, but a natural way to do this is I just want to keep on moving until I get to the food. We can't use a for loop because we don't know in advance how many times we have to loop. So how do we do this? Remember the while loop? The while loop lets us keep on looping until a condition is met. And the condition that we'll look to meet is that me is on top of food. Let's take a quick look at the while loop again just to remember what it looks like. So this is what the while loop looks like generally. It's a single word while with a Boolean, which I call a condition, followed by a colon, and then an indented body. And the body is repeated over and over again until condition is false. If condition is false the very first time it runs, then body will never be executed. Let's look at a simple example. Let's set the variable I equal to 3, and let's say while I is greater than 0, colon, print I, and I will get smaller by 1. I equals I minus 1. Now, we could of course just type this into a Python editor and run this, but a lot of times it's useful to be able to look at code and understand what it does. And sometimes, as how we found out when we were looking at the random number generator, it's useful to really dive in and figure out exactly what's going on in your own head. And often the easiest way to do that is with a piece of paper and a pencil, and I'm going to show you how we do this. What I'll often do is have a column for each variable. So in this case, we only have a single variable, so we'll call it I, and we'll put its current value just underneath it. And if the value changes, we'll cross it out and put the new value. And then we might have another place where we put the output. And now we can go through this bit of code and simulate the computer with pencil and paper. First of all, I equals 3. So we'll put the number 3 here. While I is greater than 0. Well, is I greater than 0? Yes, it is. It's 3. So let's print I. Okay, we print it. I equals I minus 1. All right, so I changes. It's no longer 3. Now it has the value 2. Okay, that was the body. It goes back to
the condition on the while loop and checks, is I greater than 0? Yes, it is. It's equal to 2. So it prints I again, and then it says I equals I minus 1, so I gets modified to 1. This body finishes, it goes back to the while loop and checks the condition. Is I greater than 0? Well, it's equal to 1, so it is. It prints I. And it says I equals I minus 1, so I changes its value, it's now 0. This body finishes, it goes back to the while loop and it checks the condition. Is I greater than 0? No, it is not. It's equal to 0. So the body doesn't execute again, and control flows with whatever follows after the while loop.
So we've run our program and it doesn't give any output at all. We have a bug. How do we debug? How do we find where the bug is in our program? Well, there's lots of ways, and in fact the way that I recommend you start is by thinking. By far the best debugging skill is to think. Look at your code and just try and understand what is going on. That actually can get you pretty far. Secondly, you can use paper and pencil. If you've got a bit of an algorithm and it's not doing exactly what you want, do what we did just a minute ago when we were looking at the while loop. That can be really helpful too. However, sometimes those techniques aren't enough, and you need to dive down into how the computer itself is executing the code to figure out what's going on. Well, so let's do that. And there are a number of ways to even do that, but the simplest way is just to put in print statements in the middle of your code to print out statements with some interesting variable values to tell you what is going on as your code is running. Well, we've got our while loop that says is food to write, and so it calls is food to write. We've got our me lock and our food lock. Maybe somehow this is always returning false, in which case the while loop would always see a false condition and it would never do anything at all. So let's look at these values and maybe that'll tell us something. Print me lock, print food lock. Alright, so I put in some print statements. Now I'll at least be able to see these values, right? Well, let's run and see what happens. And the answer is nothing at all. It's like, what? That's not what I was expecting. So clearly, is food to write is never being called. Well, how is that possible? Because it says while is food to write, and the condition does get called one time, even if the body doesn't. So that's strange. It's as if move to food is never getting called. And that's when you have the aha moment and you say, right, move to food is never getting called. We never called it. We defined these methods, but we forgot to call it. So let's go ahead and call move to food and run it again. Now, well, it's an exception, but before the exception is all kinds of stuff, including me lock and food lock. Now, one thing I'm going to do to make this a little bit more understandable is in move to food, I'm going to start by displaying the world one time so we see where we are first. Let's run this again. And now what we can see is the world as it starts, and then the first thing is me lock is an index of 1, not 2, because remember lists have indexes that start at 0. So this over here is index 0, this is index 1, 2, 3, 4, 5. So sure enough, me is at 1, food is at 5. Therefore, is food to the right is true, so it's going to move to the right and display the world, and the world is a little bit different, and it does it again. It keeps on doing that. But we have some kind of error. Food is not in list. So what's going on? Well, first of all, we don't need these print statements anymore, so let's get rid of these. Food is not in list. Let's run it without those print statements again so we can see exactly where the problem is. It says it's at line 23, but we can actually just click on this bottom. It's a link and it'll take us right to the line. And it's this line here, world.indexFood. Well, it turns out if you read the documentation for index, which you can do simply by Googling Python index, and you'll find the Python documentation pretty quick. Index requires that the argument you pass in is in the list, and if it's not in the list, you actually get an exception. So why would food not be in the list? Because it's in the list. And the answer is, it is in the list for a while until me moves over to the right and replaces food with me. Then food is no longer in the list. So it turns out we did have a bug. We can't assume that food is in the list. We first have to check for it. So why don't we start this by saying if food in list, something we've learned before, in world, then we can go ahead and do all of this. Otherwise, actually, how about this? We can do it even simpler. We can say if not food in world, return false. So if food isn't in the world, then food is not to the right, return false. Otherwise, we keep on going, and then the rest of this will work. That's a nice simple way to do this. We can run, and look at that. Perfect. It prints out the starting world, and then it prints out one line for each step that me moves to the right until finally me eats the food and it stops. Here's a thought exercise for you. Can you modify this code to work even if food is to the left of me? What would you have to do? And you can test that just by editing your initial world string to just swap me and food. You can also, by the way, test this by putting me and food in different places and see if that works as well.